Class, in this video, we begin the basic rules of integration on page 69 of your note packet. And so we're going to start with, in this video, with rule number 1, the indefinite integral of a constant. So if in the rectangle at the top of the page, if k is a constant, right? A constant is just any real number from the real number line. If k is a constant, a real number, then the antiderivative of the constant k with respect to x is just equal to kx plus c. And that makes sense because when we differentiate the right-hand side, we have to end up with the integrand. The derivative of k times x is just k, and the derivative of a constant c is 0. And so the derivative of kx plus c is just k. Okay? So looking at the examples down below, example 1, we have the antiderivative of the constant 12 with respect to x, right? So k is equal to 12 in this case. And so the antiderivative of 12 with respect to x is just 12 times x plus c. And we can verify that's the correct antiderivative by differentiating. The derivative of 12x is 12, and the derivative of a constant is 0. And so the antiderivative of 12 is indeed 12x plus c. In example 2, we have the antiderivative of 3 pi with respect to x. Remember, pi is equal to 3.141. So 3 times pi, right, is roughly 9.4248. And so k in this case is just equal to 3 pi. And the antiderivative of 3 pi is then 3 pi x plus c. In example 3, we have the antiderivative of 0. Right? Antiderivative of 0 with respect to x, right? So k, right, is equal to 0 in this case. 0 is a real number. And so the antiderivative of 0 with respect to x is just 0 times x plus c. Well, 0 times anything is just 0. And so this is just equal to c. So the antiderivative of 0 with respect to x is just equal to an arbitrary constant c, any constant c. Example 4, we have to find the antiderivative of dx. Well, what's between the integral sign and dx is the invisible 1. Okay? So this is equal to the antiderivative of 1 with respect to x. Okay? So k is actually equal to 1 in this case. And so the antiderivative of 1 with respect to x is equal to 1x plus c. And you know 1x is just x. So the antiderivative of 1 dx, right, the invisible 1, is equal to x plus c. And that makes sense because the derivative of x with respect to x is 1, and derivative of a constant c is 0.